I did mention metrology, strangely enough, because we have an excellent metrology-oriented tech corner for you here today. And this is one, sometimes we have guests come into the show to do tech corners with us, but in this case, Dirk, our intrepid editor-in-chief, I almost said managing editor, our intrepid editor-in-chief, Dirk Descharmes, is going to do this one on his own. It's from Marposs, it's the Nemo8, the Red Crown 2, and the horizontal quick set. So Dirk, take it away.
Yep, thanks, Mike. Well, like Mike said, we're going to look at a product from Marposs, and this is a manual gauging system that's kind of intended for production gauging, let's say, on the shop floor. And we're going to look at three components. We've got the Marposs Quick Check, and that's kind of this whole big fixture right here. We're going to take a look at the Red Crown 2 probes. That's the LVDT probes that are going to be in the fixture, and we're going to look at the Nemo8. Let's start with the Nemo8. So we come down here to look at the Nemo8. Right now, this is just the display. So it's a 5.5 inch display, I believe, right here. And right now we're showing the output of 4 LVDT probes that happen to be plugged into the back. You can see as I move these probes, we're seeing them move there. So one of the interesting things about this right now is we're looking at the output of 4 probes simultaneously. Now, if we, some of you are familiar with working with columns, very often you'll have a column that might look at the output of a couple of probes, a calculation, for instance, and we'll get to that in a little bit. This allows you to look at more at one time than what you might do with a column, and I'll discuss that in a little bit when we get around to the actual setup of the measurements that we're doing. Let's take a look at the back of the Nemo first. This Nemo is called the Nemo8. This happens to be an 8 USB input gauge calibration, gauge computer. See, we've got 4 inputs already used up. There's another 4 inputs down here on the bottom, so 8 USB inputs total. There's also a couple of Ethernet connectors so that you can send your data to a computer on your LAN. There's also an RS-232 connector for outputting data serially, maybe to a laptop or another computer. The Nemo is actually very intuitive to use, and I'm going to just show you how easy it is to set this up to program. Actually, let me back up here a little bit. Let's take a look at the probes real quick before we get into the programming. I think we have a picture of what one of the Red Crown 2 probes is. If we can throw that up on the screen. There we go. So you're seeing a picture here of the Red Crown 2. You can see on the right-hand side, that's the actual pencil probe. On the left-hand side is the USB end of it. And I want to talk about this a little bit. If we can come back to the Nemo. I'm going to unplug one of these. Okay, so this is the end of the probe itself. You can see that looks like just your regular standard USB connector, but inside this case, there's electronics. An LVDT probe is an analog probe. The output is analog. In order to go to something digital, which is what USB is, needs to be converted to digital. So inside this case is an A to D converter to convert the analog LVDT probe signal into a digital signal. Also in here is the electronics for correcting for small linear and sensitivity errors that would be inherent in an LVDT probe. All LVDT probes have to be calibrated. That calibration information is stored within this connector as well. So obviously you take one of these probes, you could plug it into a laptop, you could plug it into a tower and start using it right away. We're just going to plug it right here into the Nemo. And get this where I can see it. Sorry about that, folks. There we go. And if we'll just show you how easy it is now to program this. Okay, so we're going to go into program mode. Notice on the home page here, very simple menu. This is all touch screen. Measure, programming, settings, and service. We're going to go into programming. We're going to look at a part that we've already programmed. I'm going to select that part program, go into edit, all touch screen, very easy to use, and we bring up the first set of characteristics that we're going to look at for the part we're going to measure. If we can switch over to the gauge cam here, I'll show you what we're going to measure. We have a part here we're going to look at. That's this part right here. We're going to measure the front diameter, the rear diameter, and the difference between the 2 diameters to give us taper. So I'll show you how that's done on the Nemo. Look at the Nemo. We've got 3 characteristics. The first characteristic is going to be front diameter. Second is rear diameter. Third is the difference between the 2. I select that first characteristic, click Edit, and that will bring up the data for that particular characteristic. And we can see all of this is editable. So we happen to have named this diameter front. We've told it that it is an external diameter. You see a little drop-down menu there. We can select what kind of measurement this is going to be. Then there's the formula. What do we want to do with the data that we collect from the set of probes? So we have a bunch of functions that we can select from, sine, cosine, tangent, a bunch of trig functions, some other functions as well. But what we're going to do here is we're simply going to take the first probe, subtract it from the second probe to give us our diameter. We can move down. In our menu, we can set the measurement units, the precision, what type of limits, bilateral in this case, what our nominal value is, what our upper and lower limit are, 0.1 millimeters in this case. And then we can move on to our next characteristic. And I will scroll up there. So now we're looking at the diameter in back. And again, external diameter and the formula. And another thing I want to show you about the formula is because I found this really interesting in this particular interface. Once you select the type of measurement that you're going to do, and remember in this case we're doing an external diameter, the amount of functions that are available to you are based on that context. These drop-downs are context sensitive based on the type of measurement that you've selected. Now it is possible to select just a generic measurement and then you could have all of the functions available to you at one time. But if you're selecting particular types of measurement, this really is a shortcut to kind of ease the strain on the programmer, giving them only what's available for that particular type of measurement. So I thought that was a pretty nice feature. Let's just back out of this and let's go take some measurements. Okay, so we're going to go back to our home screen, click on measure, and now we're going to actually measure a part. Now, we've got our master in here right now, so we can switch to the gauge cam. This is a master part. This system has been mastered to this part. This is also going to be our pretend good part, good production part. If I come to the Nemo, I say start, we'll see on the Nemo that our part, as we would expect, since it's the master, is all within tolerance. Notice we got all green bars right there. If we were measuring a production part, we would say, hey, this is a good part. So let's drop a bad part in here. So I'm going to take a part that is obviously not the same part. We're going to drop it in there. Now if we go back to the Nemo and look at it, you can see we've got two reds, we've got a green, and in fact, I'm going to flip this part over because there's something else I want to show you. Going to take a slightly different measurement. Now we've got two reds and a yellow. This can be configured to look at, this can be configured to be just a straight go, no-go where you get reds or greens, or you can have it show, what do they call it, approach lights, and that would be the yellow. So if you want to look, am I approaching a limit, that can be programmed in too, and in this case we look at the Nemo, that shows up as a yellow. So sometimes that's valuable for the operator, rather than just a straight go, no-go, you've passed, you failed. It's nice to know sometimes when you're approaching a limit, and so we have that approach light built in there. Now as they're taking the data, once they've dropped their part in there, they've hit start, they now hit stop. That data is captured and stored. Now the operator can now take this part off, put another part on, say start, that takes the data, stop, it captures that data, stores it. They could take another part, I'll put a good part in this time. They capture, they say start, they capture the data, they say stop, the data is stored. So the value here is that sometimes you want your production operator just to quickly go through parts, pass, fail, whatever. But you want that data to be stored because you're going to need to go back, or somebody's going to need to go back and look at trend data, because that trend data, all that data stored over time on a particular type of part is valuable. All that data is stored. It can be offloaded via sticking a USB memory stick in. It can be sent over a local area network via the Ethernet connection. It can be downloaded over the RS-232. All of those outputs are available from the Nemo. Now let's take a look at the fixture itself. If we can go to the gauge here. Okay, this is a horizontal quick set. They also make this as a vertical quick set and also a chuck quick set. The chuck quick set is for chucked parts. The vertical quick set, which is kind of a vertical orientation of this, is for parts between centers. But what we've got right here is the horizontal one. This is about 14 inches wide. It could be 30 inches wide, 3 feet wide, doesn't matter. It's the size of the centerpiece, it's what you order. Let's look at these parts in here. These are standard parts, now fixturing parts. So imagine you have a base, a very rugged base that you're working with a cross member. You've got these V blocks. to hold your part. And then you got these transmission blocks, which actually hold the probe, the Red Crown 2 probes, which are going to do your measurement for you. Now notice that one thing that's interesting about these probes, here is actually, I'm not sure we can see it, there is actually the tip of your probe. The probe does not come in contact with the actual part itself. The probe is in contact with a transmission lever, which then makes contact with the part. The reason for that is when you put a part in, you don't want that part rubbing across the top of your probe and side loading it, because over time that's going to damage the probe. This way it's dropping down against a rugged little lever here, which transmits that movement to the probe. The probe is protected. Sure, the tip, the business end tip of this transmission can wear out, but that's much less much less cost to replace than would replacing a probe. And obviously, also these have over travel built into them, so you can't overextend your probe. There's actually limits that can be set on these transmission levers to prevent over travel. So all of this makes for a very rugged and flexible fixturing system, and it's really what you want. A lot of you have to deal with custom fixtures that you have to store a bunch of fixtures, one fixture for each type of part. This is very easy to take these components, which are off-the-shelf components, move them back and forth on the rail, put them wherever you need them to very quickly set up a fixture to measure a part, so much better than using like a custom fixturing, which is a cost and also a storage issue. So once again, this is a manual gauging system from Marposs. We looked at the quick set, that's the fixture. We looked at the Red Crown 2 LVDT USB probe, and of course we looked at the Nemo8 USB input gauging computer. All of this from Marposs, and once again thanks to the folks at Marposs for sending this along to us.